Hey guys, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer quiz 4 question. Altogether, we have 6 different questions this week, and let's get started with the first one. Question number 1. Suppose that 2.0 mole of hydrogen gas at 380 m and 25 degrees Celsius and 4 mole of nitrogen gas at identical pressure and temperature are mixed at constant volume. Determine the delta mix S of the gas mixture. In order for you to tackle this kind of problem, you need to do 2 steps. So the first step is you need to calculate the delta mix G, and then only you can calculate the delta mix S. So let's do it together. So we shall start with calculating the delta mix G. So delta mix G is equivalent to nRT, the summation of mole fraction, ln mole fraction. Alright, so from here, you need to know what is your N. According to the question, you have 2 different type of gas. So you have hydrogen and nitrogen, and the number of mole is given in the question as well. So your N is actually 2 plus 4, which is the number of mole for hydrogen and nitrogen. So, and then moving on to your R. So the R is the gas constant, and the value is 8.314 joule over mole times K, right? And then moving on to your temperature. So given in the question, the temperature is 25 degrees Celsius, and the nitrogen also have the identical pressure and temperature. So we can assume that both of them have the same temperature, which is 25 degrees Celsius. But since your R, the gas constant, is in Kelvin, so you need to convert this to Kelvin to 73. Then you can move on to the calculation of the mole fraction. So the calculation of the mole fraction, so I'm just going to do the hydrogen first. So the mole fraction of hydrogen is 2 plus the summation of the number of moles, so 2 plus 4 ln the mole fraction itself. 2 plus 4. And then it's the summation, right? So you need to plus the mole fraction of nitrogen. So the mole fraction of nitrogen is 4 over 2 plus 4 ln 4 over 2 plus 4. Okay, so from here you can get your delta mix G. Supposedly it is equivalent to negative 9.4619 times 10 to the power of 3 joule. So what you can do is that you can convert this to kilojoule, so making it negative 9.4619 kilojoule. So this is the first step, which is the value of delta mix G. From the calculation that we have done, we can see that your delta mix G is equivalent to negative 9.4619 kilojoule. So you can say that your delta mix G or delta G is less than 0. Hence, this reaction is a spontaneous reaction. So spontaneous reaction because of the value of delta G. So apart from this, you will also calculate your value for delta mix S. So delta mix S is equivalent to negative delta mix G or delta G over T. And the delta G that you get from the calculation is negative 9.1619 kilojoule over T. So your T is 25 degrees Celsius plus 273 to change it to Kelvin. So you shall get equivalent to negative 3.1751 times 10 to the power of negative 2 kilojoule per Kelvin. So this is the final answer for your delta mix S. Let's move on to the second question. 1 mole of helium, 3 mole of neon, and 2 mole of argon are mixed at a standard temperature pressure. Assuming that these gases follows the ideal gas behavior, determine the Gibbs free energy of mixing for this mixture. Before you can start answering this question, you need to know what is the Gibbs free energy of mixing. So Gibbs free energy of mixing is actually the delta mix G. So the delta mix G, just as the first question, is equivalent to nRT summation of mole fraction ln mole fraction. So in this question, instead of 2 gases, we have 3 different gases. So the number of mole for each gases are 1, so plus 3 plus another 2. That's your N. And your R is actually equivalent to the constant value 8.314 joule over mole times Kelvin. And your T, because it states here that it is at standard temperature pressure, so you need to understand that at standard temperature pressure, or STP, the temperature is 273. Now we can move on to do the summation of the mole fraction. So the mole fraction, because we have 3 different gases, so the first one is helium, so 1 over 1 plus 3 plus 2 ln the same value, 1 plus 3 plus 2, plus for neon, so you have 3 over 1 plus 3 plus 2 ln the same thing, 1 plus 3 plus 2, and lastly we have argon, which is 2 mole, so 2 plus 1, 2 divided by 1 plus 3 plus 2 ln the same thing. So from here, you can do the calculation and you shall get this one is equivalent to negative 13716 times 10 to the power of 4 joule. Okay, how are you going to get what is the unit here? So you know that this one is mole, and then this one is joule over mole Kelvin, and this one is Kelvin, right? So if you can see, so this mole, you can slash with this mole, and then the Kelvin here, you can slash with this Kelvin, leaving you with only joule. But if you look closely at the choice of answers that you have is in kilojoule instead of joule. So this value of joule, you need to divide by 1000 to convert it to kilojoule. So the final answer for this question is negative 13.7160 kilojoule. So make sure that you understand how you can get the unit for each question or each problem that is given to you. Let's move on to question number 3. Nitrogen gas react with chlorine gas to produce nitrogen trichloride. At equilibrium, the concentration of each gases were found to be 0.15 molar, 0.25 molar, and also 0.5 molar respectively. Determine the equilibrium constant with respect to atmospheric pressure when the reaction was conducted at 74 degrees Celsius. Let's do this question together. So the first thing that you need to do is you need to be able to write a balance equation for this reaction. So you have nitrogen gas, which react with chlorine gas, will produce nitrogen trichloride. So you need to balance up this equation. So since you have 3 chlorine here and you have 2 chlorine here, so we just want to swap it. So here you put 3 and here you put 2. So you look at the N, so you have 2N here and you already have 2N here. So this is the balance equation for this reaction. So all of it should be in gas phase. So this is the first step of how you are going to tackle question number 3. So and then the next up, you need to calculate the Kc. So the Kc is actually equivalent to whatever in the product divided by whatever in the reactant. So in the product, you only have NCl3, which is the nitrogen trichloride. So since you have 2 here, so to the power of 2 divided by whatever in the reactant. So reactant you have nitrogen, and also you have chlorine gas. So chlorine gas, because you have 3 here, so to the power of 3. Alright, some of you might ask, why are we going to calculate the Kc? Because the question asks you to determine the equilibrium constant with respect to the atmospheric pressure. So basically what you were asked to calculate is not Kc but Kp. But since you were given the concentration instead of the pressure, so you need to calculate your Kc beforehand. So now let's plug in the value that is given to you in the question. So it states here that nitrogen, chlorine, and nitrogen trichloride. So the molarity of nitrogen trichloride is actually equivalent to 0.5. So you need to do to the power of 2 divided by nitrogen gas. So nitrogen gas is 0.15 molar, and your chlorine gas is actually 0.25 molar, because you have 3 here, so to the power of 3. So basically you shall get your Kc is equivalent to 1.06667 times 10 to the power of 2. So in the question you were asked to calculate the Kp instead of the Kc. So you can know that your Kp is actually equivalent to Kc times RT to power of delta N. So now what we are going to do is to calculate what is delta N. So in delta N is whatever in the product minus whatever in the reactant. So in the product you only have 2, so delta N is equivalent to 2 minus, so we have 3 and 1 here, right? So 3 plus 1 equivalent to 4. So 2 minus 4 is equivalent to negative 2. This is your delta N. Alright, so just recap. So the first step you need to do is you need to write the balance equation for this, and then you move on to calculating the Kc. So remember, every number that you have in front become the power of that particular concentration. And why we are going to calculate the Kc first? Because you were given the concentration instead of the pressure. So you already have your value of Kc, so you have this already, and R is a constant value, and your T is given in the question, but you need to convert it to Kelvin, and your N is actually this one. So 2 is here, whatever in the product, and you need to minus whatever in the reactant. So please remember that for N2, the nitrogen gas, because it doesn't have any number in front, it's supposed to be 1, not 0. If 0 times anything will be 0, means that N is not there. So instead of 0 is equivalent to 1. So your reactant is 3 plus 1. So 3 plus 1 equivalent to 4. So 2 minus 4 equivalent to negative 4. But please understand that the calculation for delta N is only valid for those in gaseous form. So here, because given to you is nitrogen gas, chlorine gas, and nitrogen trichloride. But if you don't know whether nitrogen trichloride is a gas or not, but you can still read the question, the concentration of each gases. So all of this we assume as gas. So all of this should be in gaseous form as well. So now we are going to calculate the value of Kp. So Kp equivalent to Kc RT delta N. So your Kc is the figure that you have calculated before, 1.06667 times 10 to the power of 2, and your RT, your R is the constant value, which is 0.0821, and your T is equivalent to 74 plus 273, and your delta N is equivalent to negative 2. So you should get equivalent to this one, 1.06667 times 10 to the power of 2 times 1.2321 times 10 to the power of negative 3. So therefore you should get your answer is equivalent to 0.13143. Alright, this is the final answer for your KP. Alright guys, now we are halfway through the discussion. So question number 4. Initially 3 mole of hydrogen react with 1.2 mole of iodine in a sealed 3.0 times 10 to the power of 3 cm³ container to produce hydrogen iodide. At equilibrium, it was found that 1.8 mole of hydrogen iodide was formed. Calculate the equilibrium constant for this reaction. So the first thing that you need to understand is you need to know what you are going to calculate. So in the question, you were asked to calculate the equilibrium constant. So equilibrium constant is the Kc. So in order for you to calculate the Kc, what you really need is not the number of mole, but instead you will need to calculate the molarity of this substance instead. So given to you is the volume and the number of mole for each substance. So what you can do is you need to calculate the molarity of each substance. Alright, the first thing that we are going to calculate is the molarity of the hydrogen gas. So the molarity of hydrogen gas equivalent to mole over liter. So the number of mole of hydrogen gas that is given to you is 3 and the volume is 3.0 times 10 to the power of 3 cm³. So remember that this is in cm³, so you need to convert it to liter. So 3.0 times 10 to the power of 3 cm³, you need to divide by 1000 because you want to convert it to liter. So you will get 3 divided by 3 equivalent to 1 molar. Okay, we are going to do the same thing, the molarity for iodine. So molarity for iodine equivalent to mole over liter. So the same drill, because iodine have 1.2 mole. So supposedly the container is the same container, so the volume is 3 liter. So 1.2 divided by 3, you get 0.4 molar of iodine. So after you have done this calculation, then only we can move on to making the ice diagram. Right, so from the calculation, we already have the molarity for hydrogen and also iodine. So what you need to do now is you need to write the balance equation for this reaction. So it states here that hydrogen react with the iodine to produce hydrogen iodide. So hydrogen iodide. So since you have 2 I here and 2 H here, so it means that you need to put 2 around here. So from here you can write your ice diagram. Initially, the concentration of hydrogen and also iodine is given to you in the question, which is 1 and 0.4. So initially there will be no hydrogen iodide being formed. So here at change, everything in the reactant will be minus and everything in the product will be positive. So positive 2x. So why is it positive 2x? Is because of this. So you just follow whatever value that you have there. Alright, so at equilibrium you can have 1 minus x. So this one is 0.4 minus x, and 0 plus 2x means equivalent to 2x. So in saying so, we can write your Kc is equivalent to Hi to the power of 2 H2 times I2. So you're going to substitute this one inside here by using the x. So but you need to look at the question again. So at equilibrium, it was found that 1.8 mole of hydrogen iodide was formed. So the same thing that you need to do, you need to find the molarity for the hydrogen iodide. Right, just a quick recap of what we have done. So we have done the balance equation for this reaction, and we have written the ice diagram. So make sure that you understand. Initially, there will be no HI being formed, and then you need to make sure that you put 2x instead of x because you have 2 HI over here. So now in the question you were given that hydrogen iodide, which is appearing at equilibrium, is formed, and how much it is being formed is just 1.8 mole. So in ice diagram you need to have the molarity instead of number of mole. So since that this reaction is being done in this particular container, so means that we can calculate their molarity for the hydrogen iodide. So molarity for hydrogen iodide is equivalent to mole over liter. So this one we have already converted to liter just now. So the number of mole given in the question for HI is equivalent to 1.8 divided by 3, because this one 3.0 times 10 to the power of 3 centimeter cube, you need to convert to liter. So you will get the concentration or the molarity of HI is actually equivalent to 0.6 molar. Right. So from here, you know that 2x is the concentration of HI. So 2x is actually equivalent to 0.6. Therefore, you know that your x is equivalent to 0.6 divided by 2. So you get x is actually equivalent to 0.3. So from there, you can use this 0.3 to plug in all of the x's that you have at equilibrium. So since you know that the value of x is actually equivalent to 0.3, we just need to plug in 0.3 in all the x's. So this one is 0.4 minus 0.3, and this one is 2 times 0.3. So definitely this one is 0.6. So this one is 0.1, and this one will be 0.7. So from here, since we already have all this value at equilibrium, we can definitely calculate your Kc. Your Kc is whatever in the product, which is Hi. So remember, in your product you have 2 here, so Hi to the power of 2, and then you need to divide it with whatever in the reactant, which is the H2 and also the I2. So all you need to do is you need to plug in all this value inside here. Therefore, you shall get the value of your Kc. So in saying that, we can write the Kc equivalent to your Hi to the power of 2 divided by hydrogen gas and also iodine. So from there, we just need to plug in the value. This one is 0.6 to the power of 2, and the value of H2 that you have is actually 0.7, and your I2 is equivalent to 0.1. So you just have to press your calculator. You should get the final answer for the Kc is equivalent to 5.1428. So this is the final answer for question number 4. Let's move on to question number 5. Consider the hypothetical reaction takes place between gases A2 and B in a closed container at 800 Kelvin. So 0.325 mole of gas A2 and 2.0 mole of gas B are sealed in a 1000 centimeter cube container. After a few minutes, equilibrium is established and the content in the container turns light red with formation of 0.4 mole of gas AB. At 532 degrees Celsius, the same reaction was conducted, and it was found that the Kc for the reaction is equal to 0.79. So determine the delta H for this reaction. So the same drill as the previous question, the first thing that you need to do is you need to know how to write a balance equation for this type of reaction. So if you look closely in the question, this reaction is being carried out between two different type of gases, which is A2 and also B. So it means that when you write the chemical equation, you need to write A2 plus B, and then what is your product. So here, if you can see here in the question, it states that AB will be formed. So AB will be formed. So looking at your A, you have A2, right? So definitely you need to put 2 here. So since you have already 2B here, so you need to times 2 here as well. So from here you can write your ICE diagram, ICE. So in the question, you were given the number of mole again instead of the concentration. So the number of mole of A is equivalent to 0.325, right? So looking at the volume, 1000 centimeter cube is actually divided by 1000, equivalent to 1. So equivalent to 1 liter. So whatever being divided by 1 liter is equivalent to that particular value itself. So what we can do is that, because we don't really need to calculate more things, so what I'm going to do is we just need to write the value, because it's going to be the same, the number of mole and the molarity of these gases should be the same due to the container, the volume of the container is equivalent to 1 liter. So we can write A2 is equivalent to 0.325 and 2B is equivalent to 2.0, and initially there's no AB being formed. So here minus X, this one because you have 2 here, so you need to minus 2X. And this one, same drill because you have 2 over here, so plus 2x. In saying that, you need to have at equilibrium 0.325 minus x, so this one is 2 minus 2x, and this one will be positive 2x, right? So what else is being given to you? In the question, it states here that at equilibrium 0.4 mole of gas AB is being formed. So since that the volume is 1 liter, so it means that 2x is actually equivalent to 0.4. So your x is equivalent to 0.4 divided by 2, so you get your x equivalent to 0.2. So what you need to do is that you need to plug in all the x's with 0.2. So what we are going to do is we are going to plug in the value of x in each substance. So I've already written this down, so you can get the concentration of A2 at equilibrium is equivalent to 1.25 times 10 to the power of negative 1. And then the concentration of your 2B is equivalent to 1.6, and the concentration of 2AB is equivalent to 0.4. So now the thing that we are going to do is we need to use all this value to put in the formula for the Kc. So in order for you to calculate your Kc, I'm just going to write again the equilibrium. So A2 plus 2B will produce 2AB. So you should be able to calculate your Kc equivalent to whatever in the product, which is AB. But because in front of your AB we have this 2, so it means AB to the power of 2 divided by concentration of whatever in the reactant, so you have A2 times B. So because you have 2B here, so it means that B to the power of 2 as well. So your Kc is equivalent to 0.4 to the power of 2 divided by 1.25 times 10 to the power of negative 1 times 1.6 to the power of 2. So from here you can get your Kc is actually equivalent to 0.5. So from here you can see that you have another value of Kc, which is 0.79. So we can say that this Kc is at 800 Kelvin. So you have another Kc at equivalent to 0.79. This one shall be at it was conducted at 532, so 532 degrees Celsius. You need to change to Kelvin plus 273, so basically it is at 805 Kelvin. So by using these two values you can actually find your delta H. Alright, let's do a short recap. So at 800 degrees Celsius, the Kc that we get is actually equivalent to 0.5, but from the question, the Kc is 0.79 at 532 degrees Celsius, which we already converted to Kelvin. So at 805 Kelvin, the Kc is such. So from here, how you're going to get your delta H is by using the formula ln K1 over K2 is actually equivalent to negative delta H divided by R times 1 over T1 minus 1 over T2. So what we need to do is we need to plug in all the values here, and the value of R is the constant value, and we already know the temperature for T1 and also T2, and also the value of K1 and also the value of K2. So after we have plugged in all the values from these values, so you should be able to get your the value for delta H is actually equivalent to 3.8029 divided by 7.7639 times 10 to the power of negative 6. So after pressing your calculator, the final answer for your delta H should be equivalent to 4.8983 times 10 to the power of 5. So this is the final answer for question number 5. Now we have reached the final question for quiz 4, the question number 6, the decomposition of dinitrogen tetroxide to nitrogen dioxide has a Kc of 5.85 times 10 to the power of negative 3. At the beginning of the reaction, the number of mole of dinitrogen tetroxide and nitrogen dioxide are 9.93 times 10 to the power of negative 3 mole and 7.65 times 10 to the power of negative 3 mole respectively. The reaction was conducted in a closed chamber with a volume of 300 cm3. Predict the direction of the reaction until the equilibrium is reached. Alright, so the first thing that you need to do is you need to make sure what type of reaction that is being done in this question. So it's a decomposition reaction, means that you have only one reactant, so that reactant shall be decomposed to another product. So in this question, you were given the thing that is being decomposed is dinitrogen tetraoxide. So dinitrogen, di means 2 nitrogen, tetra means is 4. So dinitrogen tetraoxide shall be decomposed to nitrogen dioxide. So nitrogen dioxide, obviously you know nitrogen dioxide. So you need to balance up this. So because you have 4 oxygen and 2 nitrogen here, so you put 2 over here, so you have 2 nitrogen and 4 oxygen as well. So the next thing that you need to do is you need to calculate the molarity of these two substances. So you need to calculate the molarity of this one and also this one. So now we are going to start with the calculation of the molarity of dinitrogen tetraoxide. So the molarity of dinitrogen tetraoxide is equivalent to the number of mole over liter. So given to you in the question, the number of mole of the dinitrogen tetraoxide is this one. So it's equivalent to 9.93 times 10 to the power of negative 3. So divided by so it was put in a chamber which is 300 centimeter cube. So 300 centimeter cube you need to divide by 1000 so that you can convert it to liter. So you shall get the molarity for the dinitrogen tetraoxide equivalent to 3.31 times 10 to the power of negative 2 molar. So we are going to do the same thing with the NO2. So the molarity of the NO2 is equivalent to the number of mole divided by the volume in liter. So the number of mole is equivalent to 7.65 times 10 to the power of negative 3 divided by the same value, 300 divided by 1000. So you should get the molarity for NO2 is equivalent to 2.55 times 10 to the power of negative 2 molar. Okay, next up we are going to read again the question. So given to you is actually the Kc. So the Kc is given to you and then it states here at the beginning. At the beginning means that this number of mole is actually the initial. So instead of calculating the Kc, you are actually going to calculate the Qc of this reaction. Alright, so we shall now calculate the Qc for this reaction. So the Qc is equivalent to NO2 to the power of 2 divided by N2O4. Alright, so before this we already calculated the value for this NO2 and N2O4, so 0.0255 to the power of 2 divided by 0.0331. Hence, you shall get your Qc is actually equivalent to 1.9645 times 10 to the power of negative 2. Alright, so from here we need to compare with the value of Kc that is given in the question. So the Kc is equivalent to 5.85 times 10 to the power of negative 3. So by looking at these values, you can see that your Qc is actually bigger than your Kc. Hence, when the Qc is bigger than the Kc, the system shall proceed from the right to left. So it means, in other words, we can say that it will proceed from the product to the reactant. So it may produce the reactant more as compared to the product. Right, we have reached the end of the video. So I've already explained to you how you should answer all the 6 questions that is being asked in quiz 4. So I hope by watching this video, you can understand more on this topic. So if you have any question, you can write it down at the comment section below. And thank you very much for watching. I'll see you again next week. Take care and stay safe. Goodbye.